Okay, going to be working through some problems for 11.5, which is chain rule. I'm going to do let's do number 2. I'm going to skip 1, let you do 1 yourself. So number 2, they give you z is equal to cosine of x plus 4y. They give you that x is equal to 5t to the 4th. They give you that y is equal to 1 over t. And they ask you to find dz, dt, or dw, dt. And that's just because they have different variables in each problem. So I'm going to just start this problem by just going with my tree. I'm going to start z as the top variable. Z depends on x and y. And then from there, x depends on t. Y also depends on t. So I'm going to fill out this table. I get partial z with respect to x, derivative of x with respect to t, straight derivative here. Here it splits, so again, partial z with respect to y, and then here dy dt. Okay, and now what can we find here? They want d z dt. Oh yeah, because because z can be determined directly if you know what t is, right? If you know what t is, you can get all the way back up to z. So that means I can do a straight derivative dz dt. dz dt will be the sum of the product of the branches. So I'm going to do this times this, and then plus this times this. So this should be partial z with respect to x times dx dt plus partial z with respect to y times dy dt. All right, this equals, what is the partial of z with respect to x? So I'm going to come up here, derivative of cosine of something is negative sine of that something times derivative of what's inside with respect to x. So 1 plus 0, so just 1. So there's a 1 next to that. Times dx dt, so come over here, take derivative of x with respect to t. 4 drops out, so 20t to the 3rd. Plus, so we're here right now. Partial z with respect to y, so I'll go back over here, take derivative of this with respect to y. We get, again, negative sine of x plus 4y times the derivative of what's inside of this with respect to y, so we get 0 plus 4, so times 4. Okay, that's the first part, times dy dt, so derivative of this, remember this is t to the negative 1, so that'll be negative 1 t to the negative 2 is the derivative, and I think that's pretty much it. Let's see, negative sine x plus 4y. You know what I'll do? I'll try and clean it up. I'm going to bring this 20t cubed out to the front, so negative 20t cubed sine of x plus 4y. Then over here I have a negative right here. I have a 4, I have a negative. So I'm going to bring out negative is positive. I'm going to have a 4, so plus 4. Then this t to the negative 2 is really a t squared on the bottom. Then I have sine x plus 4y. And then that's it. Well, now what I would do is I go and I replace x with this here, replace y with this here, and I'd be, well, I do it here and here also. Maybe for just this one, I'm not going to do it for the rest of the problems, but just this one I'm going to plug it in. Negative 20t cubed sine of x, which was 5t to the 4th, plus 4 times 1 over t, which is 4 over t, and then plus 4 over t squared sine, and then it's going to look exactly like the other one, 5t to the 4th plus 4 over t, and that's it. Let's look at number What do I want to do next? Ugh. Okay, yeah, let's do number 4. So for 4, w equals natural log the square root of x squared plus y squared plus z squared. X is sine t, y is cosine t, z is tangent t. So of my options, it's most likely this is going to be find dw dt. But let me draw a tree here. I have w up top. W depends on x, y, and z, so I actually have 3 different variables that it depends on, x, y, and z. And x depends on t, y depends on t, and z depends on t. So since all I need to know is t in order to determine w, then dw dt, the straight derivative, is possible. So we've got our different pieces here. Partial w, be careful. W is a top variable. Did I say z just a second ago? If I know what t is, then I can get w. So dw dt. So partial w with respect to x. This is dx dt. This one is partial w with respect to y, dy dt. This one is partial w with respect to z, then dz dt. So the derivative of w with respect to t should be the sum of the product of the branches. So here's one branch, here's a second branch, there's 3 branches. So I'm going to have partial w with respect to x times dx dt plus partial w with respect to y times dy dt plus partial w with respect to z times dz dt, which equals partial w with respect to x. Ooh. Well, the first thing I'm going to do is I'm going to remember that this means, this right here, square root, really means raising to the 1/2. And then I'm going to remember a property of logs that allows me to bring that 1/2 out front. So that's really what I'm looking at. It's a little easier to take a derivative of that. So what is a derivative of 1/2 natural log of something? Well, it's 1/2 times 1 over the something, x squared plus y squared plus z squared, but then times the derivative of the inside with respect to x. So I'm going to hold y and z constant. Derivative of the inside of this with respect to x would just be 2x. So I'm going to throw that on top, 2x, like that. And then times the derivative of x with respect to t. So that's just cosine t. Plus, now the partial w with respect to y. So I come back over here, do the same thing I did on the previous one. It's going to be this exact expression, except instead of 2x, I'm going to have 2y. And I'm going to notice that those 2's would cancel. So this one will be y over x squared plus y squared plus z squared, but then times dy dt, which is going to be negative sine t. And then I have one more plus. Plus, I'm out of room over here, so plus partial w with respect to z, which again is going to be the derivative of this again, but this time derivative inside here is 2z. So it's going to look like this with a z on top. And then derivative of z with respect to t, which is going to be secant squared t. And then what you would have to do is you have to go in here and replace all of your x's with sine t, all your y's with cosine t, all your z's with tangent t, and have fun. Actually, it turns out to be really nice, doesn't it? Let's just look at this one right here. What would happen? Just that one. I'm not going to do them all. Too much work. What if I replace, if I have x over x squared plus y squared plus z squared? Well, x is sine t, so sine t over sine squared t plus y, which is cosine, so cosine squared t, plus z, which is tangent squared t. Sine squared t plus cosine squared t is 1. So this is really 1 plus tangent squared t. And 1 plus tangent squared t is secant squared t. So you have sine t over secant squared t, and you could move things around there if you wanted to. You probably get some nice, nice cleaner expression in terms of sine and cosine. But I'm just showing you how some of that's simplified. Yeah, I think you've got the gist of it. All right, next. So I've done 2 and 4. I'm going to move on and do something else. Sorry if I seem rushed, but I'm hungry and tired. All right, let's look at 6. Number 6. Arc sine, I'm going to write this, arc sine, my marker got wet. Arc sine of x minus y, that equals z. Z equals arc sine of x minus y. X is equal to s squared plus t squared. And then y is equal to 1 minus 2st. And they ask you to find partial z with respect to s and partial z with respect to t. So they're kind of telling you there's only 2 possible derivatives, but let's see why. Talked about this in class. Z is the top. Z depends on x and y. X depends on s and t. Y depends on s and t also. And so to know what z is, I've got to know both s and t. So it's only possible for me to find partials, and there should be 2 of them. One with respect to s, one with respect to t. So I will only do one of these, okay? We'll do that one, which means I'm going to go down this branch, and then down here, and then this one down here like that. So down this right here is partial z with respect to x, and then down this branch, because it splits, partial x with respect to s. Then over here, partial z with respect to y, then down this branch, partial y with respect to s. So partial z with respect to s should be product of these 2 plus product of those 2. So partial z with respect to x times partial x with respect to s plus partial z with respect to y times partial y with respect to s. Okay, what is the derivative, partial derivative of z with respect to x? So coming over here, treating y like a constant, derivative of arc sine of something is 1 over the square root of 1 minus whatever's in there, this, squared. Which number is this? 6, yeah. Okay, then times the derivative of what's inside of here with respect to x, which is just 1, so I'm even going to put it here, 1, times now partial of x with respect to s. So derivative of this with respect to s means t is a constant, so just 2s. Plus, now partial z with respect to y, same thing, derivative arc sine of something is 1 over square root 1 minus whatever was inside the argument squared, then times derivative of what's inside with respect to y. So x is a constant, that's 0. Derivative of negative y is -1. Times partial y with respect to s. So here's y. Treat this like a constant. Derivative of 1 is 0. So derivative of s by itself is just 1. But then I have times -2t, so -2t. So I could clean this up a little bit. Just pop this on top. So I'm just going to go 2s up here. Over here, negative and negative is positive. So the 2t is just going to pop up here, like that. And then you could go about replacing x with this, replacing y with this, seeing if anything cleans up, but that's pretty much it. So I did this one. I'll leave you that one on your own. Okay, let's take a look at number 8. Where is number 8? Number 8. Z is tangent of u over v. U is equal to 2s plus 3t. V is equal to 3s minus 2t. And they want the same two things here. All right, so let's draw a tree. Z depends on u and v. U depends on s and t. V depends on s and t also. So for this problem, since again, there are two possible partials, I'll do this one on this one. So we're going to go down here, down the t path, here, down the t path. So it's going to be partial z with respect to u, partial u with respect to t, partial z with respect to v, partial v with respect to t. So I'm going to go here, multiply those two, add these two being multiplied. So partial z with respect to t is, I wonder if you can do this all at one time. Partial of z, I'll write it down. Partial z with respect to u times partial u with respect to t plus partial z with respect to v times partial v with respect to t. All right, what is the partial of z with respect to u? Well, that's this, treating u like a variable. So remember this right here. Might make it a little easier. U over v is the same as 1 over v times u. And we're treating u like it's the variable, and that means that v is a constant. So first of all, derivative of tangent, was it tangent or arctangent? Tangent. Derivative of tangent of something is secant squared of that something, u over v, times derivative of the inside with respect to u, which means that this is a constant, times u, derivative of that is just a constant, 1 over v. Okay, times, now derivative of u with respect to t. So derivative of this with respect to t is just 3. Nice. Plus partial of z with respect to v, same thing, derivative of this, which is secant squared of u over v. But this time, times the derivative of in here with respect to v. So u is a constant, just hold on to it for a second. Derivative of this is negative 1 over v squared. So remember, that's v to the negative 1. So we're going to get negative 1 over v squared, but then times u. That constant came along for the ride. And then times the partial of v with respect to t, which is negative 2. And then you could start to clean everything up again. All right, so that was 8. Let's move on. I'm going to skip all the way down. Jeez. I'm going to go all the way to 20. Well, you know what? 21 looks pretty good. Let's do 21. Capital N is equal to P plus Q over P plus R. P is equal to U plus VW. Q is equal to V plus UW, and R is equal to W plus UV. Oh my goodness. They want you to find three things: partial n with respect to u, partial n with respect to v, partial n with respect to w. And they want these when u equals 2, v equals 3, w equals 4. Okay, I did not do one like this in class. Let me start with a tree. N is at the top. N depends on P, Q, and R. P, Q, R. P depends on U, V, and W. So P depends on U, V, and W. Q depends on U, V, and W. U, V, W. And R depends on U, V, and W. So to get N, I need to know U, V, and W. So there's actually three partials that are possible. These are the three partials. And I'm just going to do one of them. I'm going to do this one when U is 2, 3, and 4. U is 2, V is 3, W is 4. So that means I'm going to be going down the paths that lead me down to the U's. So I've got to come down here and then down, down here and then down, down here and then down. So down this path right here, because N splits, I'm going to have partial N with respect to P. Down this path, I might be out of room on the camera. This is partial P with respect to U. Remember, P splits, so it's a partial. This right here is partial N with respect to Q. And then down this path, partial Q with respect to U. Then this path right here, partial N with respect to R. Okay. Then down that one, partial R with respect to U. Woo! So, using this one right here, all right? The partial of N with respect to U is equal to product down this one and this one right here, which is going to be partial N with respect to P times partial P with respect to U, plus now we go down this one, here, here, partial N with respect to Q, partial Q with respect to U, plus now finally this one here to here, partial N with respect to R times partial R with respect to U. Ay, ay, ay. All right, that's what I need to find, and I'm going to need to do that when U is 2, 3, 4, so I'm going to have to get back to that. I'm done with this tree. I'm going to need some space here for these partials. So what's partial of N with respect to P? So I need to take derivative of this, treating P like a variable, Q and R are constants. So partial N with respect to P. So I have to do a quotient rule. So what's derivative of the top with respect to P? It's just 1 times the bottom, P plus R, minus the derivative of the bottom with respect to P, which is just 1 again, times the top, P plus Q, all over the bottom squared, P plus R squared. So derivative of top is 1, because derivative of Q is 0, times the bottom, minus derivative of bottom is 1, because derivative of P is 1, derivative of R is 0, times the top, all over the bottom squared. Which equals, let me see, this is P plus R minus P minus Q all over P plus R squared, which is, boom, boom, R minus Q over P plus R squared. So that's this piece right here. So this is equal to just that, that's all we've done. R minus Q over P plus R squared times partial of P with respect to U. Partial of this with respect to U, thank goodness that's a constant, gone, that's just 1. Plus partial of N with respect to Q. So how are we going to do this? partial of n with respect to q. Yeah, with respect to q. All right, so what I want you to notice is that if I rewrote this, I could go 1 over p plus r times p plus q. And so this is a constant, right? This is just the denominator popped out front. That's a constant times p plus q. So I'm going to hold off on the constant, bring it with me. Derivative of p plus q with respect to q is just 1, right? Because derivative of p is 0, derivative of q is 1. So I get 1 times that. So this is just 1 over p plus r. So that's nice. That's 1 over p plus r. Times, now partial of q with respect to u. So partial of q with respect to u, derivative of v is 0 because it's a constant. Here u is our variable, w is a constant. Derivative of u is 1 times w, so just w. Plus partial of m with respect to r. All right, so I want you to look at this again. I'm going to look at it a different way. Let's look at it as p plus q is a constant times 1 over p plus r. That's what this is. And I'm going to rewrite this at the end as p plus r to the negative 1. So I brought it up. And now I take the derivative. Remember, this is a constant. R is the variable. So I have to first do chain rule. Negative 1 comes out. Change this up here. So the negative 1 pops out. I'll put it in front of the p plus q. And then it's this right here, p plus r. Subtract 1 from the power because you took the derivative. Then take derivative of the inside with respect to r. So we get 0 plus 1. So just times 1 on the end. And this is just negative p plus q over p plus r squared, just dropping that down. So negative, why don't I pull the negative out here? Negative p plus q over p plus r squared times partial of r with respect to u. So if you do the partial of r with respect to u here, use my variable, derivative will just be v. Whoa, okay. We have our partial derivative. Now, I need to plug in u is 2, v is 3, w is 4. So let's see what happens here. In order for me to figure out the values here, I can replace, right now, I can replace this w with 4. I can replace this v with 3. But I don't see any u's in here. So how are we going to get p, q, and r? Well, we come back to the formulas for p, q, and r. Let's figure out what p is when u is 2, v is 3, w is 4. So that would be 14. Q, when this is 3 plus u is 2 times w is 4. That's 8 plus, that's 11. And then r, let's see, w is 4 plus u times v is going to be 6. That's going to be 10. All right. So we should be able to get this. This is going to be r, which is 10. Take away q, which is 11, over p plus r. So 14 plus 10 is 24 squared times 1 plus 1 over p plus r, we just said was 24, times w, which was 4, minus p plus q. P plus q is 25. That's right here. Over p plus r squared again. We did that a second ago over here. So 24 squared, and then times v, which is 3. Whew, my goodness. This is fun. All right, so let's see what we get here. Negative 1 over 24 squared. Put these two together. This is plus 4 over 24. And then over here, this is minus, put those two together. So 75 over 24 squared. All right, that looks good. And then I think what I'll do is I'll get a common denominator, 24 squared. So I'm going to take 24 and multiply 24 on top and on the bottom, so that becomes a squared. So I have negative 1 over 24 squared plus, let's see, 4 times this, it's 8, it's 96 over 24 squared, and then minus 75 over 24 squared. So we've got 96, take away one of these. Well, I'm doing this. Since they all have the common denominator, I'm doing this. So I believe the top is 20 over 24 squared. Now, let me check this. 21, I'll be pissed if I mess something up here. Remember, this is just one of the partials. My goodness, where is it? Oh man, yeah, 20 over 576. You can reduce that fraction, but that's good enough. So that's just one of them. Then you could go find the other one, the partial, and with respect to, what did we just do there? U, so you could do V next and go through the whole spiel again. Good exercise right there. All right, so 21. Let's look at 26. This will probably be the last one I do. X, Y, Z equals cosine of x plus y plus z. And we're asked to use the equations which I gave you in class, partial z with respect to x and partial z with respect to y. Now these are in your book also on page 655. So what we do first, if we're going to use the formula, is we move everything to one side. So this becomes xyz equals, or minus cosine of x plus y plus z equals 0. This right here becomes our capital F of x, y, z. And what we're going to do is to find the partial of z with respect to x, right, which is just this one. This is the only one I'm going to do. I'm going to let you do the other one. Then I'm going to use the formula that this should be equal to negative partial of capital F with respect to x over partial of capital F with respect to z. And that, so, is negative. Let me create a fraction here. The partial of f with respect to x. So I'm going to go through here. I'm going to treat all my x's like variables. I'm going to treat y and z like constants. So this is a constant times x, such as yz, minus, now the derivative of cosine of something is negative sine, so that minus negative sign is going to become plus sine of x plus y plus z, but then times the derivative of what's inside with respect to x, so just 1 plus 0 plus 0, so just 1, so I tack a 1 onto the end of that. Then I take the partial of f with respect to z. So partial of f with respect to z, there's my variable. These are constants. Derivative of this then would be xy. And then the same thing's going to happen when I take derivative of this with respect to z. The negative negative is going to become plus sine x plus y plus z. And then when I take the derivative of what's inside of this, derivative of x is 0, derivative of y is 0, derivative of z is 1. So we just tack a 1 to the end of that, and that's it. So I'll let you do the same thing for this one. The formula is a little bit different, right? I believe this is all that happens, this changes to a y. Oh, perfect timing. Perfect timing, okay. That's it for that section.